penny is thrown downward from a 300 feet tall tower with an initial velocity of 50 feet per second. When does the penny hit the ground, and what is its velocity of impact? In order to complete the problem, we're going to have to use the kinematic formulas. The first formula we're going to use is final velocity squared equals initial velocity squared plus 2 times acceleration times distance. This is going to help us get the final velocity. The other formula is final velocity equals initial velocity plus acceleration times time. This will help us get time after we get the velocity of impact. Below that, we have the units to help us make our operations. To use these formulas, we need acceleration, and we know that gravity is 9.8 meters per second squared, but the units we're using is feet, so we have to do the conversion. We know that 1 meter is 3.3 feet, so we're going to multiply 9.8 meters times 3.3 feet, which gives us approximately 32.34 feet, but we're going to round it up as 32 feet. So the problem is asking for time and final velocity, but in order to get time, first we need the final velocity. So we're going to use the formula on top. So we don't know final velocity, but we know that initial velocity is 50, so we substitute plus 2 times acceleration, which is 32, times distance, which is 300. Then we are going to continue to solve. So after substituting the values and solving for final velocity, we get 147.3 feet per second, and that is our answer for letter B. So now, after using the first formula, we got our final velocity is 147.3 feet per second. So now we're going to use our final velocity to get our time, which was our first question. So we're going to use the formula final velocity equals initial velocity times plus a times t. So we know that our final velocity is 147.3 feet per second equals 50 plus 32 is our acceleration, and we don't have time. So now we solve for time. After we substitute everything, we get 3.04 seconds, and that is our answer for letter A, our time. Now you know how to get certain values like time and like velocity with kinematic formulas in calculus. Thanks so much for watching.